In this lesson, we're going to take a look at a concept called version control. What is it? Why do I care? What does it matter? Let's take a break for some story time. So I started making C# nodes, a lot of C# nodes in 2017. As mentioned, when I started to learn C#, I got really excited and I began making all sorts of nodes for the Revit API for my Dynamo package, Rhythm. All of this code only lived in one place at the time, on my computer. And I'm not like saying like on Google Drive or OneDrive or Dropbox or something like that. No, on the documents folder of my laptop. That's the only place that it lived. I made a huge change to the code that broke everything. I messed up my Visual Studio solution. I messed up all the code. It wouldn't compile. And I lost a whole lot of work in the process because I was deleting files that I didn't even know what I was deleting. I thought I was removing them from Visual Studio. I was deleting them completely for them to be gone forever.
I am never going to financially recover from this.
I had no idea. That resulted in me having to rebuild Rhythm from scratch completely. Like completely from scratch. I need to emphasize that quite a bit. So that was when I realized I needed to figure out what the heck version control is. I did learn along the process that version control is essentially like a central file for Revit users. This includes code history and a whole lot more. So in order to learn about version control, we're going to relate it back to you as a Revit user so that way you can be a little more familiar with it as well. That way you don't end up in the same situation that I did all those years ago. What is Git exactly? It is a version control software. Git manages changes to a project without overwriting any part of the project. So it helps you merge things and kind of have all these versions of it available to you. It was created in 2005 by a guy named Linus Torvalds. He made Linux. I don't know why I added that, but that's in there. It was something that someone made, probably because they lost some work. It prevents overwriting of other files as well, of other people collaborating with you, or overwriting of your own code or files. That way you're not all screwed up like I was. So it prevents a lot of those things. Dynamo is hosted on GitHub and it uses Git as a process for version control. Git's awesome because all versions are saved by a snapshot. So you have a snapshot of every change you've made to your code. You can make changes and review the differences of the file that has been modified. Less lost work equals more time to do cooler stuff. So if you're not having to rewrite code, you have a whole lot more time to do really cool things in Dynamo or whatever else you're doing. So that's something else to keep in mind. Another thing worth noting is Git isn't unique to C#. You can use GitHub for anything. You can include your Python scripts online on GitHub and version control those as well. Your Dynamo graphs you can include on GitHub, all of that stuff. I actually built a presentation for Autodesk University on how to use GitHub, and I built the presentation on GitHub with versions, so that way I can kind of show how it worked. So that's linked in the lesson notes below as well for you to watch if you'd like to. This sounds really cool. Why don't all Revit users use version control? Any Revit user that you've shown version control to, so after this course and you're using version control, you'll show your Revit users, they're going to say, why doesn't Revit have this? Unfortunately, Revit doesn't have it and you don't know what you don't know. So learning about version control may be new to you, and yeah, it doesn't play so nice with version control and you don't know what you don't know. That being said, there is a tool out there called Speckle that enables some version control for BIM files. So I encourage you to take a look at their software as well, because you're able to do very similar actions as you are with Git with Speckle. So you're able to push what are called commits out and have snapshots of your Revit model or your AutoCAD file or your Rhino file or whatever files you want to push to their cloud. Really cool software. I really like what those guys are doing over there. Let's go over some key terminology here for Git. So the main thing here is a repository, or repo for short. You'll hear most people say repo. It's kind of just the way that we all say it, but it is a repository by nature. It's a storage space where our project can live. So this would be our C# project with all of our Dynamo nodes. This is similar to a Revit central file. So this little storage building with all the boxes in it on the screen, that's our central file. And each one of those boxes are files that we're injecting into the central file, or our repository, if you will. Another key term here is version control. We've said this a few times, but instead of saving multiple versions, it saves snapshots of every point in time for the life of a project. So it's not whole copies, save as is of files. It's snapshots of what's changed. This is similar to Revit's backup folder, but like way better because Revit's backup folder is just a mess. But yeah, it's a snapshot history of everything that's happened within your coding project. Another key term is commit. So this is the really cool part about Git, is a commit is you pushing changes to Git. Each time you commit to the repo, Git takes a snapshot to give you a checkpoint to go back to if needed. So each commit is doing a snapshot, which is really cool. And commits can exist locally on your computer only until you push them to the cloud if you'd like. So commits are something that can exist locally, which is really neat. This is very similar to syncing with Central, but it's also way better because sync with Central takes a long time. Snapshots are like, snapping. They're very fast. There are a few different ways to commit as well. In addition to a commit, you do have a push action to push those changes within those commits to the cloud location, which will be GitHub in this course. We'll cover that a little more later. Another key term is branch. This allows people to work on their own version of the project before pushing changes back to the main project. For Revit users, this is very similar to your local file that you're working on before you push changes to the central file. So you can have all these different branches that you can work on for features or different nodes or things like that for C# for Dynamo nodes. Kind of building upon branch a bit more is fork. So you can have your very own copy of a project separate from the source with the option to contribute back to the original. So this is kind of like a local file as well, but it's almost like a second central file that you can work on its own, or you can push it back to the main project if you'd like. So it's like an enhanced local file that can exist on its own or contribute back to the parent as well. Forks are very powerful, and that's how you actually contribute to the Dynamo GitHub as well, is a fork. So you create a fork, that's your own version of it, make your changes, and then you submit it to the repo at a later time when it's ready to go. That is submitted through something called a pull request. So a pull request is a way of submitting contributions to an open project. This is done by making changes on your fork and generating a pull request. So in that case, if you have a fork, like I said for Dynamo, you make your changes, test them, and you end up pushing them to Dynamo and they approve them or whatever. Syncing with Central and Revit, no one has to approve it. So a pull request is kind of an enhanced way of merging those syncs as well. And they have a full history with them. The screenshot below, you can see that there was 15 open at this time, and there's descriptions on every file that's changed. So if someone's changed a ton of files, you can see that, or one file or whatever, which is really nice. And if they touch another file that they weren't supposed to by accident, it will show that as well. And you can ask them to fix that before it's merged. Really cool way to manage code. Git kind of intimidates people quite a bit, but the benefits you gain from it are so huge. Another term that we're going to be pretty familiar with writing C# code for Dynamo is a .gitignore file. There's a special file to Git that we're able to tell it what kind of files to ignore. So if you're writing C# code for Dynamo with a bunch of nodes, you might have some sample files in there that are Revit files that are maybe proprietary or really big. In your gitignore, you can add a file extension of .rvt, and those won't get synced to the cloud. So that's really an easy way to manage those kind of things. You can also add internal files that are ignored and things like that. So that way you're telling it what kind of stuff to ignore. In the lesson files, we are going to include a sample.gitignore that I use for all of my Dynamo packages. It has certain internal build files that we just ignore because they're not needed because they're user specific. I know that's a whole lot to kind of digest, but by knowing key terms about Git, you will be very successful in your C# journey. As a reminder, these slides are linked in the lesson files for this lesson. I encourage you to save them to reference back to as you're working through this course. I will try to reiterate what each term means as we use them, as we're syncing and things like that, committing, pull requests, all that stuff. I'll try to break them down as we go through them in Revit terms as well. But knowing these terms is really key here before you actually start writing code. We'll get writing code here shortly, I promise. With that in mind, that's it for this lesson. I will see you in the next lesson.